Hello and welcome to the screencast for Chem Activity 30B, pH. Subtitled, In Water, Can Hydronium Exist Without Hydroxide? This is for Allied Health Chemistry, Chemistry 120 at Missouri Southern State University, and I'm Dr. Michael Garut. Model 1 shows the hydronium hydroxide balance. There is an equation that, a reaction equation that talks about the self-ionization of water. And then there is a mathematical relationship. In this relationship, these square brackets indicate the molar concentration, the concentration in molarity. That's what those square brackets always mean in chemistry. And so what this equation is telling you is that when you multiply the molar concentration of hydronium by the molar concentration of hydroxide in an aqueous solution, that is always 10 to the minus 14th, or 1.0 times 10 to the minus 14th. Pause the video and read that entire paragraph if you need to right now. And then we'll go straight into applying that equation on critical thinking question number 1. So go ahead and pause the video, use this equation, and do question number 1. Pause now. Alright, so here's how that gets set up. I went ahead and filled in this says coffee has a hydronium concentration of 2.0 times 10 to the minus 5th molar. So I put that here, times the hydroxide, equals 1.0 times 10 to the minus 14th. Then I divided both sides by 2 times 10 to the minus 5th. And I get hydroxide equals this fraction, which is 5.0 times 10 to the minus 10th, and then I put in the units of capital M for molarity. If this isn't what you got, pause the video now and try to rework the math, and what you need to be sure that you can do is work this math on your calculator. So try that now, and if you get it, great, and if not, I'll show you how to work that through on the Casio calculator that I suggested you buy for this class. So pause and try it now. So on the Casio calculator, you're going to put in 1.0 times 10 to the minus 14, right? And then you're going to hit the divide button, and then 2.0 times 10 to the minus 5, and then equals. If you have a different calculator, you need to verify that you can get this answer correctly. Different calculators have different orders of operations, and also many of them have a difference between the minus key and the negative key for the exponent. Some of them have a key that says plus or minus, which is the same as this key. So if you do have a different calculator, on this activity it's extremely important that every time we work through a problem that you verify that you can get the answer on your calculator, so when it comes time for the quiz, you are confident that you can work your calculator. Alright, question 2, you're going to try it again. Household ammonia has a hydroxide ion concentration of 4.3 times 10 to the minus 3 molar. What is the concentration of hydronium ion? Pause the video and work this question now. Alright, so did you get 2.3 times 10 to the minus 12th molar hydronium? If you didn't, you should go back and check that now. And then let's go on with Model 2. pH, which might be considered to stand for the power of hydrogen, is defined as the negative of the logarithm of the molar concentration of hydronium ions. In other words, this equation right here. The negative of the logarithm of the molar concentration of hydronium ions. And since earlier we said that in pure water the concentration of hydronium is 1.0 times 10 to the minus 7th, when you do the math on this, you come out with a pH of 7.0, exactly 7, in pure water. Again, you need to be able to work your calculator. So now we're going to I'll page back down here so we can see what is the pH of the coffee in question 1. Pause the video and do that now. Pause now. Alright, so did you get 4.70? If you didn't, make sure that you used the hydronium concentration for that, not the hydroxide concentration that we calculated. If you have something different, pause and rework it, but I set it up like this, minus of the log of the hydronium concentration, and the way I type that into my calculator, I actually didn't do the minus. I just went ahead and did the log, and then I put in 2.0 times 10 to the minus 5. Then I actually got a negative number, but I just disregarded the negative and wrote down 4.6989. The way that significant figures work is that there are 2 significant figures in this starting number. Oops. And since there are 2 there, I want to keep 2 in my answer, but when you take the logarithm of something, the number before the decimal does not count because it's just a placeholder, like a times 10 to the something, and so I need to keep 2 decimal places, so I'm rounding off to 4.70. Pause the video now and do critical thinking question number 4. Pause now. Alright, so this time I did have the hydronium calculated on number 2 as that answer, but in order to not introduce rounding off error, I went back to number 2, redid this math, and carried that out to more decimal places. So I have 2.326 times 10 to the minus 12, and then I get 11.63, which has 2 significant digits. Only the 2 after the decimal place count as significant. If you have a calculator that is not algebraic like this Casio, then the way that you're doing that is you're typing in the 2.326 times 10 to the minus 12, and then you press the log button. And that's how those calculators work. You should make sure, again, that you can get these answers on the calculator that you will be using on the quiz, not your cell phone. Alright, number 5. Let's do some more practice. Given the following hydronium ion concentrations, calculate the pH values of these household solutions. Pause the video and do A. Pause now. I get 1.72. Make sure you can get that also. Then pause and do part B. Pause now. I get 3.30, keeping 2 significant figures. And pause and do part C. Pause now. And I get 9.20. So this is just checking, make sure you can get these answers correctly on your calculator. So let's move on with the next page. As shown in Model 1, in a neutral solution, the hydronium ion concentration is equal to the hydroxide ion concentration. What would be the pH of a neutral solution? Write your answer now. Okay, I think you probably have an idea that the pH of a neutral solution is 7. However, if you're going to do the math, the concentration of hydronium ion is 1.0 times 10 to the minus 7th molar. And so you would do the math like this. Minus of the log of 1.0 times 10 to the minus 7th. And if you do that math, you'll get 7.0. And if you're keeping the right number of significant figures, you'll have 2 decimal places because you have 2 digits that you're taking the logarithm of. So, 7.00. Number 7. Most foods and beverages are acidic, while household cleaners such as ammonia are basic. Considering the pH of the solutions calculated in this activity, oops, so that would be these guys, all of these. Predict the range of pH values that characterize A, an acidic solution, and B, a basic solution. You probably already have some idea of this. Go ahead and pause the video and write down a range for both of those, A and B. Pause now. So you've probably seen somewhere that pHs less than 7 are acidic, and that turns out to be the case here. The beverage coffee is less than 7, the lemon juice is less than 7, the apple cider is less than 7. The further away from 7 you get, the more acidic it is, and characteristics of an acid are that it tastes very sour. So, you can imagine that the coffee itself might not be tasting that sour because it's not that far from 7, but the apple cider has a sourness to it, and the lemon juice, if you've ever had any, you know it's extremely sour. The pHs that are above 7, the cleaner 9.2 and the ammonia is very basic at 11.6. If you were to taste those, which I do not recommend, but if you were actually to taste those, you would find they taste very bitter, not good at all. Imagine tasting soap, and you'll know what a base tastes like. Not good. It's true that the pH can actually go less than 0 or greater than 14, but we don't normally see that, and so these values are ones that are commonly given. All right, number 8. If the pH of a cola drink is 3.2, what is the hydronium ion concentration? And I've given you some hints on how to work your calculator. So try that now, remembering this is the equation for pH. And that should be a square bracket. So try that now. Alright, so the answer is 6.3 times 10 to the minus 4th molar. Is that what you got? If not, let me walk through the math or the algebra on this. So, since pH is the minus log of the hydronium concentration, since this is now 3.2, the way to do the math is to take the negative of the 3.2, which gets rid of this negative, and then take 10 to the power of that. 10 to the log of something gets rid of the logarithm, and so 10 to the negative 3.2 is the way that you do this. On your Casio, you would put in 3.2, change it to a negative, and you can do that in either order. But you actually have to put the 10 to the x first. The 10 to the x key is on the log key, so you put shift log, which gets 10 to the x, and then you can put the minus 3.2 and equals, and that should get you the answer. I don't have that calculator with me right now to double check that, but I'm pretty sure that's correct. If you have a non-algebraic calculator, then the way that you do that is you just put in the 3.2 negative, and then you just hit the 10 to the x key. You need to practice with your calculator. This is the tricky one. And this particular activity is when you become happy that you spent the 12 bucks on this calculator, because it works out really nicely. So make sure you can get this answer, 6.3 times 10 to the minus 4th. Now let's go on with part B. What is the hydroxide ion concentration? So you'll need to use a different equation for that, which is given. Look back, pause the activity, and do this now. And this is how I do that one, and verify that you can get 1.6 times 10 to the minus 11th molar. Let's go on and do number 9. What is the hydroxide ion concentration in a 1.0 times 10 to the minus 5th molar aqueous solution of sodium hydroxide? Pause the video and write your answer. Pause now. Alright, so did you try to do some math on this? I hope not. This question is just to help you recognize that you've got to read carefully. In a solution of sodium hydroxide, the concentration of sodium hydroxide is given, and so the concentration of hydroxide would be the same, because in sodium hydroxide it's going to split up into one sodium ion and one hydroxide ion. So in that solution you would have 1 times 10 to the minus 5th molar sodium and 1 times 10 to the minus 5th molar hydroxide. So you don't have to do any math there. This is the answer. Okay? Well, I should have left that. So what is the pH of this solution? And it says be careful. All right, pause the video and do that right now. All right, did you get it? The pH is 9.00. This is a hydroxide solution. It should be basic. If you got something that was less than 7, that should be a warning sign to you that you did not do the math correctly. In order to do this, you're given the hydroxide concentration. You first have to calculate the hydronium concentration before you can do the logarithm and change that into the pH. So verify that you can get that one. All right, number 10. What is the pH of a 1/10 molar solution of HCl? Pause the video and do part A. Pause now. All right, so you remember how to do this one, or let's remember how to do that. So HCl in water, and that gives you hydronium plus chloride. This is an acid-base reaction. You remember how that works. A proton gets transferred to the water to become hydronium. Hydronium is the conjugate acid of water. That leaves you with chloride ion, which is the conjugate base of HCl. So if you have 1/10 molar solution of HCl, we need to figure out the concentration of hydronium. So is HCl a strong or a weak acid? You should know that it's strong because you've memorized them. So based on that, what is the concentration of hydronium? Pause the video and write your answer. So I say it's 0.1 molar. That's 1/10 molar. Why is that? If HCl is a strong acid, what do we know about strong acids? They dissociate 100% or completely, and so however much HCl I have, that becomes that same amount of hydronium because 100% of it is converted into hydronium, so 1/10 molar. So part D, go ahead and calculate the pH. Pause now. And you should get 1.0. 1/10 has one significant digit, and the 0 is the one significant digit after you take the pH. So it doesn't take a whole lot of acid, 1/10 of a molar, to make something very acidic, a pH of 1.0. So how do you feel about pH? In the exercises, you get many more opportunities to practice your pH calculations. You can check your answers on Blackboard in the exercise solution category. And this concludes the screencast for activity 30B. Cheers!